talk about Java, and you may wonder, wait a second, this is 2025. Do we really need to talk about knowing Java? So the things I'm going to talk about today here are what I call as stub your toe moments. And I don't know whether stubbing my own toe hurts more or seeing others stub their toes hurt more. But what I've noticed is almost in every one of these situations, these are things that I've noticed people make mistakes. And I'm a big fan of automated testing. But most of the examples I'm going to show you here, test will not catch it for you. I'm a big fan of static type languages where compilers can catch your errors. Most of the things here I'm going to show you, compilers won't tell you you're wrong either. So we're going to work through a few set of problems and see how we are going to look at the behavior of the code. And then we will understand what the issue in the code is and move forward. For this session, you will need your smartphones. So keep them out. We're going to do an interactive session. The response is completely anonymous, so nobody knows who you are and who is responding. You're not in an interview. You're not being judged, so don't worry about it. Answer to the best you can, and you are encouraged to talk to the person next to you. So feel free to make a lot of noise. Ask them what they think. Put in your opinion. See what they think. They can put their opinions as well. Are you ready? Okay, I want to see the phones out. All right, excellent. I'm going to give you a QR code. You're going to point to the QR code. I'll give you a little bit of time. So let's start with the warm-up. This is not a real problem we're going to look at. This is going to just help us to make sure you're able to connect it, especially people in the back row. If you're able to point to the QR code, let's see if you're able to, right? So let's get to that. So here's your first question for you to answer. So point your cameras at it and respond to the question. You can talk to the people around you. It's a good thing. Don't be quiet. Did that work? Awesome. What about people in the back over there? Is it awesome? Thank you. Very good. Okay, should we look at the response? Here we go. So what did you say? Let's take a look. So you said we had 156 responses so far, and 68% said less than 10 years. 28% said more than 10 years, and a small percentage said more than 20 years. And this 3% of the people, they are the liars. Because Java has been only around less than 30 years. So let's wait for those 3 people to leave the room. So unless James Gosselin is in this room, right? Because I'm sure he's used it for more than 30 years. But Java is turning 30 in May, by the way. There's still 2 more months. So if you've been doing this for more than 30 years, we need to talk. Okay, good. So we had a little warm up. Let's get to the content now. So here's our first question we're going to work with. So this is a code we're going to look at and see how this code behaves and what it does. So here's the code. And this is not the QR code, so don't be in a rush to click on it. So I'm going to kind of park it here so you don't get confused. All right. So that's the first one we saw, right? How many years you've been working on it. So let's move to the next one. So what do I have here? So notice we have a list integer equal to new numbers is equal to new array list of numbers. And I'm going to print out the values in this list, which is 1, 2, and 3. And you can see it printed 1, 2, and 3. Then I call a remove 1, and then I print out what's in it. It prints out 1 and 3. So my question to you, and again, remember, you're allowed to talk to people next to you, right? My question to you is, if I change the list to collection, like so, from the list to collection, what's going to be the output? Hey, don't say it. You click on it right there. You can talk to the person next to you, but don't scream out the answer, especially the wrong ones. So we change list to collection. That's what we did. That's the only change we made, right? We changed the word list to the word collection. Question is, so we had 156 people respond last time. Let's see how many people do it this time. If you've not had a chance, that's the QR code. Point your camera at it. For those people who just walked in, you need your phone. Point to the QR code and respond to the question. And talk among yourselves. Don't be quiet. You're not in a museum or a library, right? It's like, shh, don't talk. Talk. Make noise. Ask your colleague. Ask your person next to you. Ask your friend, what do you think? Right. All right, shall we look at the responses? So here we go. What did you say? We had 72 response. Good, nice work. Awesome. And 52% of us said the response is 2, 3. 38% said 1, 3. A small percentage, 4% said 1, 2. And this group, 6%, you have my respect. You took the courage to say, I don't know. I wish more people can do that, right? To say, I don't know, rather than giving a wrong answer. So the respect goes out to that 6%. And if that 6% includes those 3 people from the last time, that's even better. But only they know it. We don't know it, right? It is their little secret they carry out from this building. So that's okay. So something, but look at the responses here, right? But there's something we can learn from these examples. So let's go ahead and run this code so we can see what the response is. And you see the response is 2, 3. That's exactly what somebody said earlier also, right? But this is something we can learn from. Now, here is what just happened, right? So we have a list of integer. That's what we started with, if you remember. So let's go back to this and use the list. And when you run the code, it gave us 1, 3 as a response. So what happened? This remove 1 ended up with a remove with a 1 where that was the index, wasn't it? So essentially, in the 1, 2, and 3, it removed 2, which is the element at index 1. That's what I listed. But the problem is that collection has a method called remove, which takes an object as a parameter. So in this case, when you go here to modify this list to a collection, notice it removed the object 1. Because when you gave a 1, it on collection, it took the object, auto-boxed 1 to integer, and removed this. Now, in Java 5, right? In Java 5, list has a remove object. They already have this. But in addition to this, they decided to add one more method. And that method they added was remove with the int index. This is also known as bad idea. Why is this a bad idea? This is a lesson we can learn from. Because they made a mistake, but it's a great way to learn what the mistake was and how we don't repeat it. This is actually something that goes wrong in a special edge case. Normally, you won't see this problem. But because a number 1 can either be an index or can be auto-boxed as an object, it ends up being the 2. But what's a lesson we can learn from this? The lesson we can learn is program with intention. So if they had called it as remove at index, the beauty of that would be it's very clear what the intention was, right? So rather than calling it as a remove, if you had named it remove at index, then the intention is extremely clear. This is something for every one of us to learn. So when we name things, you can always write a documentation. But to me, documentation should never be used to cover up bad code. Instead, you should refactor it. You should write the code in a way it's expressive. So when you say remove at index, there is no ambiguity. But if you say remove, then the question is, what are you removing? Are you removing an object? Are you removing something at an index? And maybe it's not a problem most of the time, because you may know clearly it's an object you're giving me or a number which is an index, but there is this overlap, the edge case where both of them are similar and you may not really know. So this is an example where overriding and overloading at the same time is quite dangerous, because it's very difficult to get it right where you overload and override at the same time. And so when you're doing this, it's important to take more time to analyze the code, more time to think about the consequences so that we don't get into situations like this. But I also have to tell you, this is a bit unfair, right? But the reason is, this is a very small error, not a huge one. But we live in a very unfortunate world, unfair world. I make a lot of mistakes. They make very few mistakes. But when they make a mistake, 10 million people know about it. When I make a mistake, 3 people know about it. My wife and my 2 kids. That's the only difference here, right? So it's very unfair in terms of how much exposure the errors can be. So this is a lesson we can learn still from this experience and see how we can deal with it better. But let's go a little further with this. So here is your next problem for you. In this example, we have a collection, and the question for you is, if I take this out and replace this with a var, like so. And again, before we go, right, when I run the code, it's 1, 2, 3, and 2, 3. But I'm going to make the change over here. So the question to you is, what is going to be the output of that code? So let's see if you can answer that. So point your cameras at it. Talk to the person next to you. You get to choose which side you want to turn around and talk. See what they have to say. Key in your response. It's perfectly okay to ask the person next to you. Call a friend. See, he's calling right there. Shall we take a look? Let's see how many people were able to respond to this one and what your response was. So here we go. So we had a total of 175 responses. 64% of us said 1, 3. 23% of said 2, 3. A small percentage says 1, 2. And 10% said my stomach hurts. So let's talk about this one. As it turns out, that 68% got it correct. That's good. Pat on your back. Now, this was an example where I'll talk a little bit about type inference. Don't get me wrong. I'm a huge fan of type inference. I really like type inference. But just because we like it, it doesn't mean we do it everywhere. There are times when type inference is a great idea. There are times maybe we should avoid it. This is an example where we should definitely avoid type inference. So what's the model of the story? When you run the code, it gives you 1, 3 in this case, right? Rather than 2, 3. But what happens is this. So the first model of the story is when you use type inference, be sure that the type inferred is exactly what you want it to be. So when you have this line, the first line that you see here, right? What's the type of numbers? It's obvious, right? The type of numbers is collection of integer. But when you use a var, what's the type of numbers? It's an array list. So you went from a base interface type to a specific concrete type. How does that make a difference? Now, clearly in this example, because of the error we saw earlier, it ends up calling a wrong function. But let's take this in general. What is happening in general? If you have an interface, if you have a base class, right? So if you have an interface or a base type, so the methods in this case, you can call are only those that are part of the interface or base. And you know this, if a method exists only on a class and not on its base or interface, you can call it from here. But if you change to var in this case, you can now call methods that are available, right? Only on the class. And you ask the question, did I really want that? So this is where moral of the story is. Use var when you really know that the type you're expecting is very much the type you want it to be. But if it's no longer this type, it is more specific than being general. Remember one of the good rules to follow in programming. As much as possible, you want your references to be of an interface type than a class type. So this is not a reason to say don't use type inference. No, that's not my recommendation. But be aware of what you're doing when you use type inference. You got to know, you got to understand how the code behaves as you work with it. Now, earlier I said that when the JDK team makes a mistake, 10 million people know about it. When I make a mistake, only 3 people know about it. Well, this one is a little different. This mistake, 4 people know about it. But the 4th person was somebody who read my book. But this person was extremely kind. Rather than posting on social media that I'm stupid, instead they took the time to drop me an email and say, "You are wrong." And that's what is beautiful about learning from the mistakes. And I made that mistake when I wrote the first edition of functional programming in Java. Of course, this is why you write the second edition of books. So you can fix all the errors in the first edition and you can make new mistakes in the second edition, right? So this is a mistake I made and I learned my lesson the hard way. But I want you to see if you're able to find my mistake as well. So here is the code for you to consider. So notice I have a list in this case over here. And in this particular example, what I want to show you here, you know what, pardon me, that's a wrong example, so ignore that for me. I apologize for that. I'm going to try this one more time, and let's see if we can bring the code I want to bring. So let's try this again. There you go, that's better. So here is the code I want to show you. So notice I have a arrays.asList right there. Oh, by the way, this is not the QR code, so I don't want you to jump on it yet. Okay, so I have an arrays.asList, and the value is 1, 2, and 3. Then I call add. If the add succeeds, I quietly move forward. Nothing happens, right? If the add fails, I say add unsupported. Then I call set. If the set succeeds, I go quietly. If it failed, I report set unsupported. So there are a few different combinations that you have. The result can be no errors, or the result can be add unsupported only, or it can be set unsupported only, or it can be both add unsupported and set unsupported, right? So there are 4 combinations available. Your mission, if you choose to accept it, is to tell me what it is going to be. Should we look at what we said? So this is the as list, and we have 160 responses. How does that look? We have 177 responses. So, well, okay, 179 responses. This is late voting. 182 respond. Are you calling other people outside the room and asking them to respond to this too? Cast your vote on this. You're trying to make it more even, right? This is, I mean, look at this for a minute, right? And when you look at this, we got about 1/4 of the people saying that it's add unsupported and set unsupported. We have about the same percentage saying add is not supported, some saying set is not supported, and a few saying both of them are fine. Now, if you were to interview people, which one would you hire, right? So that's kind of interesting how this is so evenly split. All right, awesome. 202 responses, great. 203 responses. So what's the verdict on this one? Well, as it turns out, the mistake I made is that the array list, the list created by as list is immutable. And the answer is no. That's where I was wrong. I claimed it's immutable. Sadly, it's not. It is sadly mutable, but you only cannot increase the size of the list. So as a result, the add is unsupported, but the set is possible. So notice the original list was 1, 2, and 3. The response has 1, 2, 2. The set actually did not complain. That was the error I made. So 1/4 of us got it right. That also tells us 3/4 of us got it wrong. But I will tell you that 1/4, ignore them. The other 3/4 in this room, you are my true friend. Because you knew the answer, but you gave a wrong answer, so I don't feel so bad. So I want to thank you for that. Otherwise, you're going to say, my gosh, this guy made a mistake. He's going to go home tonight really sad. So thank you for the 3/4 of the people in the room. You're so kind. Thank you. Well, moral of the story is the following. Quit using as list because Venkat got it wrong. But more important, use list of instead. I'm a big fan of list of. Let's see why. So if I take this code that is here, let's comment this out for a minute. As you can see, it's add unsupported, right? But if I change it to list of instead of as list, notice now both add unsupported and set unsupported. This creates an immutable list. You say, really? How do you know? If I output numbers right here, dot get class, the proof is in what it creates, isn't it? If I know how to type today. There we go. So if you notice, it's immutable collections, $list n. So it creates an immutable list right there, and that's what the list of does. So you can use list of, set of, map of. Those are all functions added in Java 9. So you can use those methods. Question?
So they when you see start off, then it is very get a null pointer. Waiting with.
Oh yeah, good question. Null is evil, right? It's better to avoid it as much as you can. But unfortunately, somebody out there is going to mess with nulls. So what if you have a null here, right, is the question. You got a null pointer exception. Absolutely. To me, which is good, because you're able to, assuming we do this thing called testing, right? So we can test with those scenarios, and then we can program defensively. We can start writing code to filter those out ahead of bringing the data in. But because you're creating a known set of values, there's no reason to put a null into it.
Because that's the list with the testing and the tag null value, then also took.
Yeah, you shouldn't. We need to really avoid using null as much as we can. If you Google for a $1 billion mistake, the gentleman who created null apologized publicly. He said this was the worst mistake he made in his life, right? So don't use null and try to program defensively to deal against it. So off is creating an immutable collection. This is a much better way to write the code. And you can use, just like I said, you can use list of. Similarly, you can use a set of, like so. and you can provide a list of values like 1, 2, 3, and whatever values you want to. So if you create a set of those values, for example, if I were to create the set of like so, and if I were to create the set, you can see that set is 3, 2, 1. It's just that sets don't give you ordering. But what if I have a duplication of data? It says duplicate element. So sets don't allow duplicates as well. So that is an error it produces right there. Similarly, you can provide a map of maybe a 1 and an A, and a 2 and a B, and so on. So this creates a immutable map as well for us to use in this particular case. And that can be a very powerful way for us to create a map as a collection as well. But all of them are immutable. So you cannot add to a collection created using the off function. So that's one of the things that you can do nicely. Now, we looked at a few examples, but up to this point, if you noticed, in every single example, your compilers did not catch the problem. So the code compiled, but the result was not what we expected, at least not what 3/4 of us expected, right? For example. But you could argue in those examples, you could have unit tested the code and you would have found out what the issue is, right? That's a fair statement. You could have figured this out by unit testing. But the next one I'm going to show you, compiler will not catch the problem, and a unit test will not catch the problem either. This actually is code an email I received. I cannot tell you the company name, but this person works for a company that maintains a lot of people's retirement accounts and mutual funds and hedge funds. And what this person had done is take a particular person's portfolio, look at all the funds the person has, perform a series of transformations on it, and this person had the code. And the email I got that morning was the following. The email said, "Hey Venkat, here's a small snippet of code from my application." And his email went on to say, "This code worked fine until yesterday. But this morning I made one change and all hell broke loose. What am I doing wrong?" That was the question. Now, obviously, I can create a code with mutual funds and all of those good stuff, but that's not going to help us because that's going to be a lot of clutter. So I've transformed the problem to something a lot simpler so that we can take a look at the code and see if we can answer what that code is doing. So here is the code. I have a list of Dory, Gil, Bruce, etc. I have an array list I've created. I go through a stream, convert all the names to uppercase, and then put that into this in uppercase array list. I print the size of the original list, which is 1, 2, 3, 4, 5, 6, 7, and I print the size of the resulting list. In fact, I'm going to run this for you. It's 7 and 7, right? As you can see. So the question to you is the following. What could possibly go wrong in this code? Let's see what our 200 friends here are saying about this. All right. Before we look at your responses, an honest question. Raise your hand if you have seen code like this in your production systems. Yeah, the hands go up, right? You know what? I've been telling people not to write code like this. Every opportunity I get, I tell people, don't do this. So you should have seen my shock when one morning, in a code base only I maintain, there's nobody else changing this code. And I opened the source code one morning, and in my source code, I saw a code like that. Now, in my defense, I did leave the window open. Who knows? Maybe an alien came and updated the code, right? The point is, I know not to do it. And yet, I found a similar code in my own system. That's what is shocking. Because a lot of times, when we are solving a problem, we tend to forget the consequences of what we do. But what could be wrong in this code? Let's see what you said in observation, right? So let's take a look. And we had about 192 people. The 8 of them checked out. Let's see what they said. 54% said the lambda pass to for each has a side effect. That's correct. 30% said the lambda pass to for each should be a method reference. You know why? Because that has no consequence. And we sometimes solve problems like that. 7% of us said that nothing, it's beautiful the way God created.
That's so that's the
And another 7% said, I have a bad feeling. Yeah, me too. So, this code has side effect, but let's see what the problem is. And what is the consequence of the problem? Let's take a look. The side effect, in this case, is right there in that particular line of code, right there, right? What is the side effect? This code, this lambda is mutating a shared mutable variable. That is the problem here, right? It's mutating a shared mutable variable. So when you're in the functional pipeline, it puts its hand out and modifies that variable outside the pipeline. Now, you can run this code several times, right? So I'm going to say, run this code, and I'm going to run it many times, right? Doesn't matter. I'm going to ask it to run a lot of times. And it doesn't matter because this code is really, running through the pipeline. It is sequential in nature. That's enough. Let's run this, right? No problem, right? So it seems to be running fine. But I'm going to make one change to this code. What change would make this scary? Make it a parallel stream, right? So the only change I'm going to make is this. Parallel stream. By the way, this code right here, there's a name for it. It is a ticking time bomb. Why is it a ticking time bomb? Now, somebody wrote that code in your production system, right? You raised your hand earlier. You've seen code like this, right? Somebody wrote that code. And you know what that person did? They quit 3 months ago. They're happy somewhere else, writing that code in that system, in another company. And somebody came along and they decided to change the stream to parallel stream. And that person may also have quit. But guess what the code is doing? It's just running fine until it doesn't. And on that Wednesday, it fails. And you lose customer data. And up to this point, there's no problem, right? Except on that Wednesday, you are on call. You have the phone, right? And your phone rings at 2 a.m. in the night. Your family is not happy because your phone woke up everybody. And they're like, what happened? There's a production problem at work. And you got to go to work and they tell you you lost customer data, fix it. And you're staring at this code. Can you easily find what the problem is? You're scratching your head. I don't know why it's not working. And you run the code again. Guess what it does? It works. You call your colleague, this failed. And the colleague is looking at it like, run it. And you run it. It works. It's non-repeatable, right? Except it repeats the problem in production. So here's my analysis of this. Let's go back and take a look at this code, right? So we make the change in this code. Let's go run it again. Isn't that beautiful? Not consistent. So here's my observation. Forget it works on my machine. If you are lucky, it fails on your machine. If you are not lucky, it fails in production. So my slogan today is not it works on my machine. My slogan today is it fails on my machine. Because if it doesn't fail on your machine, but it misbehaves elsewhere, we're in trouble, right? So what's the problem in this code? The problem, as you suggested, is the side effect. So we got to learn a few things. Let's look at this code for a minute. What did it do? It is mutating a shared mutable variable. Let me emphasize this. It is okay to mutate. Let me just emphasize it. Sometimes we learn concepts halfway and get super excited about things. It is okay to mutate. You say, really? I can mutate in functional programming? Go for it. You can mutate. Just that, make sure it is okay to mutate, but please make sure that your mutation is not visible outside. Mutation is like changing clothes. I hope you did, right? If you didn't change clothes, you're not going to have others sit next to you. You're going to be stinking, right? So it's okay to change clothes. I only ask, please don't do this in public. That's exactly what mutation is. You can mutate all you want, but just don't do it in public so others can see it. So mutation is okay, but visible mutation is not. So the idea is, it is our responsibility to make sure that lambdas are pure. So what is a pure function? First of all, a pure function, you could say, has no side effects. You could also say a pure function is idempotent. So what is an idempotent function? An idempotent function is a function that gives you the same exact result no matter how many times you call, as long as the input is the same. So a pure function is idempotent. You can get the same exact response repeatedly for the same input. But I'm going to say two rules of purity. And when I say two rules of purity, the rule number one is going to be obvious. You're going to say, of course, Venkat, we know what that is. But the rule number two, many people don't think about it. And I would argue, while rule one is necessary, it's not sufficient. You need both the rules for purity. So what is the two rules of purity? Rule number one, a pure function does not make any change that is visible outside. Notice that is visible outside. I'm not saying it shouldn't make any change. Go, make any change you want to make. But the change shouldn't be visible outside. If you're changing local variables within a function, who cares? That's perfectly fine. It's still a pure function. But if you're making the change outside, that's not pure. So a pure function does not make any change that is visible outside. And I would say rule one is obvious, right? You're going to say, of course, if a function is making changes outside, we'll immediately say it's not pure. A pure function does not depend on anything outside that may possibly change. That's your second rule of purity. A pure function does not depend on anything outside that may possibly change. If that may change, and if I depend on it, then I can no longer be pure. Why? Because you're going to ask me the question, when did I call you? Did I call you before the change? Or after the change? Or in the middle of the change? And now we can no longer be predicting what the output will be. It's no longer idempotent. Because if you make the change to the outside state and call my function, the result is going to be different, isn't it? So the rule number 2 is as important as the rule number 1. So they both have to be honored for purity. But let's dig in a little bit more with this. But before we do, let's go back to this code for a minute. This code is doing something completely unnecessary in this particular case. And what is it? What is it doing unnecessary? It has taken up more work to give you less result, unfortunately, in this case. So in this example, if you will, what I can do is, rather than doing it this way, I can say in uppercase equal to, and rather than this for each, all you had to do was just call toList on it like so. This will be thread safe all the time. So don't have to call for each and mutate that within the function. But instead, simply call the toList method. The toList method will, in a very thread safe manner, create the result and give it to you. You actually are writing less code than you otherwise did. So that's a lot better than the previous one. But let's take this to the next level for next example. So here is the code. So what is this code doing? We have a factor, which is an array, as you can see. And the factor has a value 2. Numbers is 1, 2, and 3. You call the stream, and then you call the map, and you say number times factor 0. You put that in a stream, set factor 0 to 0, and then you print out the result. So the question to you is, what's the output of that code? Let's give it a try. Shall we look at the response? Let's see what you had to say. So here we go. And we had about 63 people respond. That's good. And about 53% of us said 0, 0, 0. So 53% of us said 0, 0, 0, right? About 26% of us said 2, 4, 6. About 13% said, I have no clue, I want to go home. I like that response. About 8% said 1, 2, and 3. So what is going to be the response here, right? Well, we need to understand that streams are evaluated lazily. And because of lazy evaluation, in this particular case, what's going to happen is that when you call this function, the stream that you see here is not even being evaluated yet. It's not executing yet. It executes only when the terminal function is called. So by the time we modified the factor to 0, so as a result, the output in this case is all zeros. But that's because of lazy evaluation. But more important, this fails rule number 2, right? We saw that earlier. What does rule number 2 say? Lambda expression shouldn't depend on anything that may possibly change outside. So in this case, the factor is changing outside, and we're not supposed to do that. That's basically what's happening in this case, right? So as a result, the behavior is hard to predict for a lot of us. But this is the question you want to ask. Do you want to create maintainable code, or do you want to have a code where 50% of the people looking at your code either get it wrong or want to go home, right? And also, this is even worse. If this code was written in Kotlin versus Ruby versus Python versus JavaScript versus what is going to be the behavior in each of these languages? Do you want to rely on the code's behavior? Because this is a problem not of syntax, but one of semantics. And now you have to keep in mind and understand the semantics in each one of these languages, as if we don't have enough problems already. So I often ask this question in an interview. If the person tries to answer the question, they're fired already. The right answer is, are you stupid? Why do you do this? I'm like, you're hired. Because the worst kind of people to have on your job are the people who like to create Java puzzlers. They have to write code that's clear and easy to understand. So this is the kind of code we don't want to be writing, because it's incredibly hard to maintain that kind of code. Besides, you are violating one of the tenets of functional programming, which is the function has to be pure, right? That is something for us to keep in mind. So something to be careful about. But one more, maybe the last one for us to consider. So here's one more for you. We have a list of stream we call parallel, we call a map, and call transform in it, we call sequential, and we print. The question to you is, we know the stream is not a parallel stream, but we call it a parallel. We are running transform. In transform, we print the thread. Then we set sequential, and then we call print. And in the print, we print the thread. The question to you is, which thread will the transform and the print run in? That's your last problem to solve. So point your cameras at it and see if you're able to identify it. Stephen, what's your answer? Didn't mean to put you on the spot.
Right, spoil it.
You do. You're a nice person. Thank you. Yes. Is it hurting? A little bit? You're like, huh? What? This cannot be this simple. Shall we? So here we go. Let's take a look at what the response was. We had about 162 people respond. Look at that response. So we had about 25%, half of the room, said in the common pool only. 21% said either main or common pool. 18% said, please, can I call a friend? And 35% said in the main thread only. Sweet. The majority in this case wins, but let's take a look. It turns out when you run the code in this case, you can see it's all in the main. So what's happening? In the way the stream is working, remember one thing about streams. Stream does not run at all until you call the terminal function. Keep that in mind. It's not going to execute until you hit the terminal function, right? So on the line where the cursor is, when you execute that is when the whole stream is evaluated. So up to that point, only building the stream. So you said, create a stream, done. Make it parallel. Okay, it's parallel. Call a map, will do. Make it sequential. Oh, it's sequential. The last one wins. So whatever you call the last is what takes effect. Same way, if you go back here and you put parallel, the whole thing runs in parallel. But if you then put sequential, the whole thing runs sequential. So whichever is the last call changes the state. So essentially what's happening here is that a stream has multiple properties. A stream may be ordered or unordered. Similarly, a stream could be sequential or parallel. In this case, you're just changing the state of the stream from sequential to parallel or parallel to sequential, and based on that, it takes root and executes it. You notice that in every single one of these problems we saw, the compiler never gave you an error. Don't get me wrong. I'm a big fan of statically typed languages. I want compiler to be there to help me. But just because compiler is there to help me doesn't mean it's going to catch all my problems. In most of these examples, you may or may not get help from unit testing. I'm a big fan of unit testing as well, but that doesn't mean unit testing will help solve me all the problems. At some point, you still need to understand the semantics. And oftentimes, syntax is something you look at, but you have to go beyond that and be able to see the semantics in the language and understand how things work and why things work as well. And if you don't, you're going to have problems in code. And like I said, some of these problems I've run into myself, some of the problems I've seen other people run into. And when these problems occur, it becomes a lot of trouble finding where the problem is coming from. But this is what I mean by knowing the language. It's not about learning the syntax of the language, but to really understand how things work and why things work the way they do as well. So I hope you're able to leave this room with a little bit more insight than you came in with. Thank you so much for being here. That's all I have.